All right, so let's start with worksheet 22, and I'm going to start with question 1. So it says to graph the functions x sine 1 over x and the absolute value of x and negative of the absolute value of x on the same set of axes. And eventually we're going to use those graphs to observe the squeeze theorem visually and to compute the limit of f of x as x goes to 0. So you can, so I drew my graphs down here, and the solid blue line is y equals the absolute value of x, and the dashed blue line is y equals the negative absolute value of x. And we're going to use the fact that sine of anything is between -1 and 1, and therefore x times the sine of anything is going to be between the absolute value of x at most. So it's at most the absolute value of x and at least the negative absolute value of x. So think about this and make sure you're comfortable with that reasoning. And so that's why when we're looking at the graph of f of x equals x sine 1 over x, it oscillates between the absolute value of x and the negative absolute value of x. Okay, so I tried to put in some more details, and so I tried to actually draw where f of x is going to cross the axis. And I just used the fact that sine of n pi is equal to 0 for any integer. And so therefore I know it must cross the axis for x equals 1 over n pi. Of course, n not equal to 0. Oops. It should be n pi. All right. Yeah, so I tried to draw out a few of those zero crossings. Of course, as n gets larger and larger, it's going to be harder to draw those crossings. So I just drew about 3 of them and then kind of sketched out the rest of the behavior. So what we're looking at for f of x is a function that's oscillating and dampening as x goes to 0. And so in this case, if we're asked for the limit as x goes to 0, it's the sandwich theorem is definitely going to help us out. So yeah, so oscillating and dampening, let's consider using the sandwich theorem. And you know, when we're just starting off with using the sandwich theorem, it can be helpful to kind of follow the same steps every time. So I always think a good first place to start is by writing down the function itself. So in our case, the function is x sine 1 over x. And then the next step is to write down an upper bound. And as we discussed, the upper bound is going to be the absolute value of x. And I've put down the reason as well. And the next step I always think should be to write down the lower bound, which in our case is minus the absolute value of x. Okay, so finally we're going to put the lower and upper bounds together. All right. And now as x goes to 0, we see that both the lower and upper bounds converge to 0. And therefore by the sandwich theorem, that's going to force the squeeze theorem or sandwich theorem, that's going to force the thing in the middle to also go to 0. By the way, I use the word sandwich theorem and squeeze theorem interchangeably. So I hope that's not too confusing. So by the squeeze theorem, our function has a limit 0 as x goes to 0. And of course, like once you start getting more comfortable with the sandwich theorem, the theorem, you may not have to write down all these 3 steps, and you might go straight to step 4, and it's much quicker for you.